Hello everyone. So for our chemistry and physics topic this week, I decided to focus on astrophysics and black holes. So space is something that's always been really fascinating to me, and I decided to use this week as an opportunity to research a little bit more about it. So I started off with browsing NASA's website and a couple other databases to gather some key definitions and concepts. I read a little bit about NASA's current Great Observations missions, including the Hubble Space Telescope, the Chandra X-ray Observatory, the Spitzer Space Telescope, and then I also researched just the universe in general, just some kind of broad concepts there, the Hubble constant, and cosmology. So the sources I found emphasized how the universe is expanding and accelerating at extraordinary speeds and size. And the size, shape, and age of the universe is based on primordial radiations. And the Hubble Space Constant is needed to estimate the size and age of the universe. And it indicates the rate at which the universe is expanding. So those two things kind of go hand in hand. The Hubble constant and then kind of evaluating the size, shape, and age of the universe. Cosmology is just the general study that seeks to understand the evolution of our universe. So now that we have those kind of key concepts defined and understood a little bit better, we move on to black holes. So black holes are one of the things about space that I think are terrifying and so intriguing at the same time. Just the way that they can defy the laws of physics and that there's so much for us to still learn about them. I think that's just really neat. So I focused on that a little bit. They were originally predicted by Einstein's theory of relativity. They consist of a great amount of matter compacted into a small area, and we know that they are present in the center of most galaxies. And one of the articles I mentioned talked about kind of the reasoning behind why scientists think there's a black hole in the middle of the Milky Way galaxy. We can observe black holes by considering their effect on nearby matter. We can't just go into them because, like I said earlier, black holes defy the laws of physics, and if we tried to go inside one, we wouldn't come back out. So we can observe kind of their effect on nearby matter to notice their presence and just kind of see how they interact with things in their neighborhood, as some of the research called it. And they can be characterized based on mass, rotation, and charge. So the information that we currently have allows us to detect black holes through observing their interactions with other matter in their area. We can characterize them. We understand a little bit about where they come from and some of the things that they can do, but considering how they are mind-boggling even for our astrophysicists in the sense that they defy the laws of physics, there's still a lot for us to learn about black holes, and I'm really excited to see what all the great scientists come up with. So thanks for listening or watching, and I hope you guys had fun researching this week.